So let me start this topic. So this problem in the symmetric key can be solved by asymmetric encryption algorithm or asymmetric key algorithms. Okay, so in the symmetric key encryption, guys, both the parties have the same key. If you have this A, this also have A as a key. But asymmetric key, okay, what we will do, okay, we will create a one single key that is called private key. Okay, well, let me even start in this way, just to quickly give some basic terms here. So in asymmetric key, we have two different keys. One is called private key, okay, and one is called public key. Two different keys we have. Okay, so let's say this is a key name called, and let me use the term in this way. This is the private key, and this is the public key we have. Okay, the beautiful thing about this key is the property, and why they have this property, I'll go very deep into this class. The great property of this key is, okay, if you have any plain text, and if you want to encrypt this plain text, okay, and convert it to cipher, same example of encryption, cipher text, and for encrypting this cipher plain text, we need a key, and there for encryption we can use public key for encryption. This key encrypt. Okay, but cipher text, if you want to decrypt, obviously without decrypt, how can you use it? If you want to decrypt, okay, so same public key, the way you use the key that you use to encrypt this plain text to cipher text, same public key you can't use to unlock it. Only and only way to unlock or decrypt this cipher text to plain text is with the help of private key only. Okay, it means if you have one locker, one vault you have, okay, in this vault you have two keys. What are the two keys we have? Okay, if you lock this vault where you have money and other currency and jewelry, something like this, right? If you have two keys, one is public with you and private with you. Okay, open, the lock is open, you put a lot of money over there, and if you lock this locker with the public key, okay, after this vault been locked, okay, same key, the key that you use to lock, you can't use the same key to unlock it. It won't possible, it won't work. Why it not work technically, I'll tell you in a minute, but it won't work. Only way to unlock this lock is in vault is to use public, sorry, private key. Private key is only one who can unlock it. This is one of the great properties they have. Okay, and with the help of this property, we can solve a lot of challenges that I was talking about. I'll tell you one by one. Okay, but why this won't work? Okay, if anything is locked in public, it won't be unlocked with a private. I will go very deep into this concept to make you understand. Okay, but just keep this property in mind so that you can understand the remaining part of it. Okay, so we have two keys, one is public and the private keys. Okay, this is one thing. Now in this concept, okay, this is a name, different keys, but asymmetric is just concept. Then this is concept, these two names come up, but we have a lot of asymmetric algorithm in the market. Okay, one of the very famous one is called RSA, is one of the algorithm. I'll talk about this algorithm very deep. One is called Diffie-Hellman. This is also one of the algorithm we have for this concept. Okay, I'll explain this algorithm in detail. For example, you know, the way we have AES or DS for symmetric keys, similarly we have a RSA and DH and some more algorithm for under asymmetric algorithm. It means if you want to create a public and private key, you can use RSA algorithm to create it. Okay, to create it. So what I'm doing, guys, before I go more deep into this topic, let me first show you some commands so you guys can comfortable with this concept. Okay, so what I'm going to do right now, I'm going to show you how can you create a private key and the public key, okay, with the help of RSA algorithm. Okay, let me first explain you this concept to you. Okay, so what I'm going to do right now, I'll open my command prompt in my Windows, or let me open my different command prompt in Windows. Go git bash is one program that you can download from the internet. It gives you a Linux kind of command prompt in Windows. You can use any prompt in you can use anywhere, wherever you have the OpenSSL command. Okay, so what I'm going to do here, let me go to my document folder. I have this cryptography training folder already created, I believe. Yes, we have. Let me go to this folder. Right now, some file we have that what we created in the last classes. Okay, so what I'm going to do right now, okay, in asymmetric algorithm, okay, whatever you use, let's say you're using RSA. So RSA is a name of the algorithm. It's very famous. Okay, algorithm we have in the asymmetric algorithm. Okay, but in asymmetric algorithm or asymmetric concept, I can say, okay, the rule is first you have to create a private key, and from the private key you have to drive and create public key. This is how it works. Okay, it won't come in parallel, right? You can't, if you know it won't like this. You create two pieces together. Just private key also created together and public also created together, or you can't create it individual. Okay, the rule is, even though I'll tell you this rule also with very detail, because a lot of guys doesn't know this rule, why this rule we have. But let's say this is the rule I'm talking about. First, you have to create a private key, and from the private key only you can drive and create a public key. You can't directly create it. It won't work in the vice versa also. You can't create public key directly and create a private key. Okay, I'll tell you in depth why, but this is how it works. Okay, but both the key you need if you want to encrypt and decrypt. Okay, so let me do in this way. So what I'm going to do, okay, there's a command called OpenSSL. Okay, in this command, I can say I want to generate a RSA key. This command called gen RSA. Okay, and guys, you know, in the key world, normally we have to give the key size. Even though if you go to RSA algorithm in cryptography. Okay, this is the algorithm I'm talking about. Okay, so RSA is the name actually comes from their designers, is Ron, Rivest, Shamir, and Elmin. Whatever RS come from the name of their designer. Is a public key crypto system. What is public key crypto system? We'll discuss again. And if you talk about the RSA key, the key size is between this range. Okay, between 2048 to this one. Typical means you can give more or less also. You can give 1024 also. You can give 5112 bit also. It will work. But typically, mostly in the market, we use in this range only. Okay, but 102, 5112 also can be possible, for example. Okay, but one of these concepts is very powerful. That's what I will explain you the RSA in very detail. Okay, but let's say I want to create a key of size 1024. And when you hit enter, that's all, your private key will be created. Okay, so what I'm creating right now here is the private key. Okay, private key I'm going to create. Enter. So finally, guys, your private key, RSA private key has been created. Okay, and when you guys run again one more time, one more pre-created. So this is a different name, RKQ something. If you create one more time, it's again different name come up. Okay, every time you create, it will give you a different number. But technically, you have to create a key once, right? To keep it secure, we can store this key in one file. Essence called my.key. Okay, or my RSA.key. Key is a normally typical extension we always give. It's not compulsory to tell there is a kind of private key. So this key is stored in a file. Okay, in this file, they store the private key. This is very sensitive. Okay, if anybody get the access of private key, they can do a lot of break. Why? I'll tell you the entire setup. The way I try to explain you here is symmetric key. Okay, hacker. Same thing I will again explain you how to use the private and public key, but I also want to show you very quickly some commands here. So this is private key created. Okay, now from this private key, okay, from this private key, you can generate a public key. Okay, you can generate a public key. Public key can't be generated directly. Okay, if you want to generate the public key, you have to first create a private key that I already created here. Okay, now private key created. Now from the private key, you can create a public key. Okay, how? Then we have a command called open SSL. I want to use RSA as a algorithm, and I'm going to give my private key. This is my private key, and I'm asking this private key. From this private key, I would like to generate pub out my public key. That's all. Okay, and this will guys create a public key for you. Okay, but from private key, I'm generating a public key. Okay, enter. So this is the public key you have. But it always generates from private key. Without private key, won't generate. Why? I will tell you the details I'll go through. If you run one more time, guys, exactly same output gonna come. Because one private key will generate the same public key always. Okay. So where we run hundreds of time, maybe. Okay, this private key is going to generate the same public key only. But now we have a public key also. I also want to store the public key in one file. Let's say this will my pub dot, for example, pub. Normally, guys, public key, normally file, typically we give the extension pub mostly, but you can give txt other things also. Now we have a private key with us, and we have a public key with us. Both the keys we have. Okay. Now, if you want to encrypt or decrypt, how can we encrypt and decrypt the data? Okay. So from this key, how can you encrypt and how can you decrypt the data? Okay. For this, I'm going to tell you the step, because the idea will be something like this. Okay. Plain text. Let me write one more time. So if you have any plain text, if you want to encrypt, convert to cipher, we use public key. Okay. Public key we use to convert. But what's the idea how we're going to use it, right? So how can we use it? So typically, what can we do? Let's say we have the A and we have the B. Okay. Let's say A want, let's try to understand the scenario. Let's say A want, okay, that B is going to send some data to me. For example, let's say A is a Gmail server and B is the client of the Gmail. So A want or Gmail want, the client want to send something. Maybe client want to send the password to Gmail. Let's say password may Red Hat as a text. In this case, okay, if A want to receive some data from somebody and they want secure connection, okay, so this guy is going to generate two key. Okay, this is called A private key, which is private key of A, and again the public key of A. That's what, let's say, we have already generated. Okay, private key and the public key we generated. Okay, and here again, hacker is also listening over the internet. Their communication one single channel over the internet. Okay, because internet like is open, nobody can stop to listen over the internet, right? Everybody can listen somehow to each other. Again, something like this, right? So now here hacker is now here, because we're using asymmetric key, is not a symmetric key. So if B want to send some data to A say don't send directly. Internet is not secure. Do one thing, wait for 1 minute. Okay. My first step would be I am the one, okay, is going to send my public key, not the private, to you. Okay. So you can receive my public key. I told you guys, internet is not secure. Hacker is also listening. Same communication. A hacker is also listen, and hacker also copy this packet and store a public key in their laptop. They can copyright, because till now everything is clear text, like a normal. This data is also like a clear text. There's a key look like very different, but it's like a password. So A is going to send the public key okay, over the internet, this key that hacker also copy in the laptop. Okay, now A tell to B, okay, now do one thing, whatever data you want to send Red Hat, log this Red Hat with me, my public key, means encrypt this. It means now B is going to send Red Hat data logged with public key of A. Okay, so in the second communication, B is doing this and sending to the A. Now what A received? A received this log data as called ciphertext. Okay, inside this log, what we have, we don't know because it's logged with the public key. Okay, exactly same data hacker also received. This is the same data because they keep on sniffing. They receive this data and what they get, a Red Hat logged with a public key. Okay, now what hacker has, they have actual data but in ciphertext that's not understandable and the A public key. What else hacker has? Nothing. Does hacker have any private key? No, they don't have any private key. Okay, they don't have private key because A is not going to reveal the private key over the network. This private key they keep secured in their own personal hard disk in the laptop. Okay, now hacker has only two information, one this and this one. Now hacker tried to use this public key to unlock, but it will work? No. Okay, because I told you guys, okay, the way public key, private key work, if you lock your data, plain text data in the ciphertext with the public key, okay, then only way to unlock or decrypt is the private key. Why? I'll tell you in some minute, but this is the rule, this is the concept we have. Without private key, it is impossible. It is impossible, little impossible to break or to unlock or to decrypt this key. So at this point in time, what hacker has a public key. From this public key, it won't able to unlock it. It won't work. So they won't able to get my real data of the P. But when the data reach to A, okay, A want to use this data. So A would want to unlock this data. Can they unlock? Answer yes, because A has their own private key, or because the data has been logged with their own public key. Okay, and A has their own private key here. So you can use their private key to decrypt this data, and what they get, they will get your main text. And they use it where they want to use. They maybe give login access to the system B and something like this. Okay. In this case, now B communication has been given to A, or B data has been sent to A, okay, in the very secure way, in encrypted way. Even though everybody is listening, but nobody can break it. And we are not sharing our secret key here. See here, there's no secret key we are sharing. Okay, share key we are sharing, or we are not sharing our private key also. Okay, only public key we are sharing, because public key we can only use, one of the use, even though there's some more use we have public key, we'll see in the future classes or future discussion, I can say, but we can use public key mostly for encryption. Okay, and if you use encryption purpose, nobody can able to decrypt without having the private key. And this guys also can solve one more problem, is one-to-many kind of. Okay, in this example, same thing we can do. Now, instead we create hundreds of different keys for everyone, A will create only two keys. Okay, one A create as a private key and one A create as a public key. And anyone who want to communicate to A will share their public key to everyone. B keep my public key. A also keep the exactly same public key. D also keep my A public key same. Okay, so in this case, if B want to send something to A, B will log their data, okay, with the public key of the A, means B want to send to the A, so they use their public key and send it. Or because A has their own private key, they can log and use it. Okay, other guys also have the same public key, but same public key they can't use to unlock it, so nobody can misuse that data, can see this data. Okay, so if everybody and when one-to-many, one guys want to communicate to thousands of guys to get the data, then having the asymmetric key, means public-private pairs, will makes a lot of sense. Okay, so guys, this is one of the use of it. Even though in this setup we have some kind of problem, we'll discuss in the problem. Okay. And to solve those problems, we will move to a concept called hybrid encryption. What are this? We'll discuss in a minute. But let me show you these things with a demo. Okay. So let's say you want to guys want to send some data to me. So in my case, I will send my public key to you. I never send my private key. Private key is most sensitive. If anybody get your private key, they can unlock all the data coming to you. Okay, if it means you get the private key Gmail. Okay, any data going to Gmail or bank, you can lock. Okay, so it's very sensitive. Okay, but let's say I'll share this public key to you, and you want to send some data to me. For example, you're going to send some data to me. Let's say plain data, plain text to me, contain let's say my name, or maybe my password. Let's say Red Hat. Okay, so in this file we have this data, or let's say this is your laptop. Okay, and you have what? You have my public key with you. Okay, now how can you lock this data or encrypt this data? So again, in OpenSSL, okay, we have a one command that I want to use. RSA utility is one command we have. Let me check this command we have. Yeah, we have this command available. In this utility, we have options, which is the help, or what are the way they have the help available, option available. Okay, in this option, what I want from this command, I want to do some kind of encryption. I want to do some kind of encryption. This one, encryption with the help of public key. Okay, so have an encrypt. Okay, and for encryption, where is your key? Which key you have? Let's say you are the B here. Okay, B here, you have only public key. So which public key you have? You have this public key. I'm going to give this public key, and for where the message in. Okay, and for the message, where my message would be in a file called plain.txt. And what you want the message to be stored? Let's say cipher dot pher.text. So I am the B here, or sender here. I want to encrypt my data. So this is what I am going to use. Okay, I'm going to use, or I can say there's, I think there's one command called in. Let me run if this command run. Yeah, there's a one error come up because guys, right now in key is a keyword. In key is a keyword that take the key, but you have to specify what kind of key it is. It is a private key or public key. In my case, I want to give a public key. You have to use this option also. What kind of key you are using? So your input key is called RSA key. So you have to use this option also here. And the key that I'm giving right now here, because same command we use for decryption also. So right here, this key is for my, is a public key of mine, not the private key. Okay, enter, and that's all. Okay, your plain text has been logged into the ciphertext. Means your data has been encrypted. Yeah, there's a pure encryption format we have. It's purely encrypted. Okay, who has done this? This client who has the data and only the public key. So I see in this command, I only use a public key and using the data. I don't have the private key. I can't use it. Okay, and this text, their mail, their WhatsApp, whatever the medium they have, they can use it. Nobody can break it. Even though we can share this data also in HTTP connection also. Normal data is a normal file. Nobody can break this kind of file. This may be mail, this may be mail. You can send. Where are you sending here? You're sending this data to A. What A received? A received this data. Which data? This file. So A received this file. However do you send it? Okay. A hacker can also receive this file, but hacker won't be able to decrypt it because they don't have the private key. But I am the A. I have my own key. This is called my RSA key. So let's say I am A, I have my RSA key. So how can I decrypt? Okay, again, I can same command open SSL. RSA util is the one option here, or utility. Okay, and in this option, I again going to say I would like to decrypt. In this case, DRYPT decrypt. Here I'm going to use a key. Key is called my RSA. And by the way, key, we will always treat this key as a private key only. And even though this is private key, so I don't have to write any other things. And my input file is set this file. So this command is run by A because A has a private key. Or their private key, they can decrypt it. Okay, see, guys, this is a command. But if you try to decrypt with public key, because everybody has the public key, if you try to decrypt with public key, you can't use the public key to decrypt. They will give this error, it won't work. It's not a private key, it won't work. Only the private key can able to decrypt this thing for you. So I'll share this command to you, okay, in a minute, or maybe in the doc. But the point here is, while by this command, I'm trying to tell you, encryption can done by public key, and decryption can only be done by private key. Okay, in the asymmetric world. And because of this behavior, then doing the encryption, okay, in this channel or internet is so simple. Okay, but what a challenge we have in this asymmetric key. Okay, one of the challenge, even though I'll tell you some more challenge. Okay, even though this setup, what you're seeing right now, is also hackable. Okay, the setup that I'm talking about here is also hackable. Okay, even though you can take as a task from my side. Okay, the setup that you see here, how can we hack this setup? Even though you use RSA with bigger powerful key, 1024 bit is a big number. Okay, but this setup, hacker can break very easily, very easily. Okay, I'm giving this task to you, and I will give this answer tomorrow in my tomorrow class. Okay, but I'm taking this task to you, just guys to go and think, maybe read somewhere, maybe, and think, how can you break this setup? How can you break? How can a hacker get the data from? Break means the motto is, I want to see my client data. That's the motto. So how can client see the data of the client? Okay, over the network. I don't want they go into the system and break the password. I'm talking about all the network. Okay, all the data is going on here and there. How they can break this client data? So think I will give this answer tomorrow. Okay, but it's breakable. That's what I'm trying to tell you. But I'm talking about other issue. Okay, in asymmetric algorithm. Okay, let's say I'm talking about the concept. The algorithm name is called RSA. Okay, the challenge we have with this in this algorithm is, okay, they are very bad in the terms of performance. Okay, it means if you are sending any data from A to B, okay, and sending means every time A send to B, B send to D, and lots of data we keep on exchanging, right? You're uploading something, downloading something, sending email, files, every bit, every second we keep on sending some data, and every data, both the side we are encrypting and decrypting. Okay, and RSA algorithm is so slow, or not only RSA, I can say almost all the asymmetric algorithm is so slow. Okay, it means if you are sending a normal text data, let's say you are sending 1 MB data, just I'm giving a random example, 1 MB or MIB data. Okay, it might take 1 second, for example. Okay, but if you're sending 1 MB data, okay, the encryption, it might take 1 minute or maybe 10 seconds, maybe, for example. There's a huge difference. It's not a very fixed number, it may be more or less, but I'm trying to tell you, okay, in the term performance perspective, okay, it takes that much time to encrypt, decrypt, and send the data. Okay, so performance perspective, if you're using an asymmetric algorithm, okay, it will slow down everything. Okay, and everywhere, guys, see Facebook, YouTube, we have encryption, right? So how can we are working there? How they are very faster, right? So that's what we'll discuss sometime. Okay, when I talk about the hybrid encryption, right? But let me show you guys how we can check the performance in a multiple way, but there's one tool available. Okay, one tool available through which we can check the performance. So in OpenSSL, if I don't know they have this option here or not, speed is one tool. If you want to see the speed of RSA algorithm, okay, so this tool is doing some testing here. Okay, again, the speed is belong to your system also. In my current laptop, in my RAM and CPU, they are uh, uh, dynamically created or randomly created a private key of 3052 bit and try to send some bits on it to encrypt or to decrypt, and this is the time they're taking here. Okay, in 5112 bits, in 10212 bit. In this current operating system right now, the RAM and CPU we have, even though I have a good RAM and CPU in my system, but there's much of time they're taking to encrypt or decrypt with this kind of key size. Okay, and what are these numbers? These are the total data they're taking randomly to encrypt and decrypt with this key, and they're talking about the average. Okay, here in some minute they show you the summary also is about RSA. But same speed tester if I use for symmetric algorithm. Okay, here in this case of performance. Okay, so if you just talk about performance, the performance of asymmetric algorithm very bad. The performance symmetric algorithm is great. So this is an area where symmetric algorithm we always want to use. Okay, just for example, in the plain text, if encrypted decrypting will allow 1 MB data, let's say it take 1 second. So maybe in symmetric they might 2 or 3 seconds, for example, but asymmetric they might take 20 seconds. Okay, this is just a rough example number, but this level of differences we have. Okay, and again we can't compromise. We need security, no doubt, but if my application is slow, what my guys. If my application is slow, nobody gonna use my application, right? That's also one point that we should understand. Okay, so they're just checking guys multiple different key sizes, and finally guys they give you summary about the differences. Okay, but same tool if you test. Okay, here this show you the summary of this much bit of science and signature and verify is not important, but they're talking about speed. Okay, the speed would be this much in this key, and bigger the size is, more it takes that time per second. Okay, so for verifying, let's say verifying would be something like this encrypt decrypt. So this is speed per second, right? Smaller key, high speed is big. Bigger key, small is the whatever they're doing. What is signature? What is signature? Also, we'll discuss in my tomorrow class. This for digital signature. We can use RSA for digital signature also. Okay, but I believe you can see this. Let's say this is speed. This is MB per second, kilobyte per second, right? Or vice versa maybe. Okay, so this is speed of the RSA. But if you try to compare with AES, okay, AES let's say with 128 bit, with some mode, let's say CBC is one mode you guys know. Mostly we use this. And if you see the speed of AES and try to compare, okay, in the summary you'll see there's a big difference in the numbers gonna come. Okay, and here even though they are working on testing on very small data, more and bigger data you have, more and more time in connection. So conclusion guys, conclusion over here is, okay, even though guys they're talking kilobytes, right? Here I think there was in this in byte. So this many kilobytes they can per second they can process. Okay, even though there I think there was in just in bytes. Okay, so whatever they're doing in conclusion here is by showing this speed test, the performance test. Okay, if you want to If you use symmetric key, hacker can break your key very easily. You security will compromise. But symmetric key is great in the terms of performance or encryption, decryption. They give you high performance. But if you use asymmetric key, as such, according to the example what I explained to you, even though it's also breakable by somehow. So what I will do, we'll take the best out of asymmetric key and best out of symmetric keys. Here we can take this guy for the performance perspective, and we take this guy for the higher security offering they are doing it. We use both the guys together in the entire communication, and then it is called hybrid keys or hybrid encryption setup. Okay, how we can use both. Okay, so let me give this idea, and this will also guys solve the challenge of what I was talking about initially. Is called key exchange. Okay, there was a challenge guys in the symmetric key, right? How to send the share massive key. If you share your AES key, then nobody can break it. But sharing of the key exchange or key is very difficult, right? So hybrid key setup guys will solve this challenge also. How? So let me explain this concept guys. This is a very, very interesting concept. Okay, and this concept has been designed by what I'm going to explain you. Okay, this hybrid key concept is designed by Diffie-Hellman. Okay, as a concept. Okay, so we search for Diffie-Hellman algorithm. Okay, or maybe key exchange algorithm. This algorithm DH, Diffie-Hellman algorithm. Okay, so this is the guys who designed this concept. What I'm going to explain you in a minute. Okay, in a minute. So that is called. So that is the initial algorithm we have is called DH algorithm. Okay, and then after this there are multiple algorithms created, or along also multiple algorithms created like RSA and other thing also. But what this algorithm will do is algorithm is example of hybrid encryption, what I'm talking about right now. So how and what they do. For example, again, same setup. Let's say we have one computer, let's say A, and A would like to connect to B and vice versa. Okay. Even though guys, in the older setup asymmetric, we had one issue. Apart from breakable, what I was talking about, I'll tell you tomorrow. But we have one issue. In this setup, okay, private keys only belongs to A. Then B can send encrypt data to A, but if A want to send some data back to B, A can't do. A can't do, right? But A don't have any public key of the B. Okay. So in this setup, B can only send encrypt data, but A can't send encrypt data. So any data come from A to B, that can be also breakable. And to not break if you don't want to break this thing, so again B also have to create B private key, then B public key. Okay, and then this B public key, B have to first send initially when A send the public key, same time B might have to also send the B public key to A. Okay, so both the parties has their own respective different public keys. So it means if B want to send some data to A, so B will encrypt this data to A public key. If A want to send some data to B, now A has the public key of B already been sent. Even the hacker can also copy, but they can't do anything because they don't have the private key. So if A want to send some data, A will log this data with a B public key encrypted and send the data to B. And because B has the private key, B will use their private key to unlock and see the data. Okay, just by adding some extra lines or extra things. Okay, both the communication, both the side will be encrypted. Okay, that's one thing. But this is all one extra thing we have to do here. Okay, but even though this setup, what I'm talking about is again breakable. How the breakable that you guys should think, I will tell you tomorrow from my side. But let's come to a main point here. Okay, So in this setup, what I've explained to you, both the parties has to create their uh, private key and public key pair. Then both the side encryption will be work. Okay. But in the hybrid setup, guys, we don't have to do this. We don't need to create both the side encryption. Okay, in the hybrid key. How? For example, let's say A is my Gmail and B just like my laptop here, my laptop Vimal. Okay, I want to send data from Gmail, G want to send some data to me. How can we do? So in this case, Gmail, okay, Gmail is like me. There might be hundreds of more different clients and thousand more kind of Gmail. So what Gmail will do, Gmail will create, let's say this A, Gmail will create their own private key. I'll show you how. From the private key, they will create a public key. I'll already show you how. Okay, and whenever any client want to send something to Gmail, so first this client come to Gmail and say, I want to say something to you. Okay, right now they're not sending any data, but they are requesting here. I'd like to send something to you. And Gmail say, wait, don't send, it's not secure. So in the reply, Gmail will respond with their private, it's not obviously not private key, public key, this key. And we will download this, get this public key of the Gmail, Gmail public key. Okay. Now, in this case, what Vimal will do, let's say we want to send some data password ahead, but they won't send this password data right now. Okay, because two things we know in the asymmetric key, two challenges we have. One, it is very slow, it will hit the performance. And second thing in the symmetric key is, if both the side we want encryption, so B also have to create their private key and public key pair. This extra step we have to do it. Okay, and extra private key public key might also impact more performance. Okay, these are two issues right now that we know. Okay, so what we will do now in this case, rather than B send their data directly, what B do in their laptop, B will create one shared key that is called symmetric key in this laptop. Okay, so let me use this key name is called S key. This is called shared or symmetric key. Means your normal symmetric key, let's say from the algorithm called AES. They create this key. Okay, but why they create this key? Because I want my next communication will happen on symmetric key, so things will be very faster. That was the motto. But challenge was, how can we share the symmetric key? Because last time when I showed you in this diagram, the way I started today, okay, if you share your symmetric key, directly hacker can read it. Remaining combination they can read. Okay, but in this case, okay, if B want to send the symmetric key to A, so remaining combination can be done on the symmetric key. So how we can send? Now this key B will encrypt with the public key of A. This big key is like a data only. I'll show you my last to last classes. They will encrypt with the A public key and send over the network. B send this data over the network. What they send? Symmetric key logged by A public key. In this case, can hacker take this data? Obviously, yes. Why not? Hacker can take this data, where the symmetric key is the main thing what we're looking for, but it's been logged by A public key. But to unlock this data and get the main symmetric key that we're going to use for further communication, okay, A need a private key, but A don't have the private key of A or Gmail. It is only keep safe, secure in the Gmail hard disk. In this case, A won't able to compromise this data. Okay, and this data will reach to Gmail. Okay, what Gmail will do against this data, they reach symmetric key created by the client, let's say in my case, Vimal, A, and A public key. Because A has the private key, they use this private key to unlock and to decrypt this data. And finally, what they receive? They receive the symmetric key. Okay. So finally, now both the side we have AES, DES, whatever the symmetric algorithm we use, we have both the keys. Okay. And guys, that was the actual challenge initially what I was talking about. There was challenge. Okay. Because initially, if you're sharing this key directly over the network on open channel, openly, like a normal text data, a hacker can read it. And challenge I was talking about the key exchange, how we can exchange the key. So now here in this case, I'm exchanging the key. Okay, that now A also have the same key, exactly same key. B also have same key. A also have. Okay, hacker also try to break, but they weren't able to unlock and they were able to find it. The key has been exchanged. Okay, so just one or two or three communications, right? We are using asymmetric key. So it means we are using asymmetric key only for exchanging the symmetric keys. Okay. Now after having the symmetric keys, now further communication between A and B, okay, they are using with their symmetric keys. You guys know symmetric key is not breakable directly, but they're so powerful like AES. If A want to send the data, they log with the symmetric key. Same symmetric key B has the unlock. B want to send the data, the same symmetric key A can unlock. But no other guys can unlock this data. Okay, and so it means your symmetric key exchange. And one thing, cool thing about symmetric key is in the performance wise they are very faster. You know, that's what I was trying to tell you. They do encryption decryption very powerfully compared to asymmetric. So you get the performance also. Okay, you get the performance also, and other issues was one to many, and those kind of issue also has been solved. Okay, and this concept is called key exchanging concept. So asymmetric key encryption actually not meant for encryption, even though we can do encryption. I show you already in my command line. Asymmetric algorithm is not actually creating for encrypting your normal data. We can do it, but because the performance are very bad, we don't use in the real world. I don't think so anybody use it in this way. Okay, instead we use encryption, asymmetric encryption for encrypting and decrypting not the plain data, rather than my private keys, not private key, actually the symmetric keys or shared keys to exchange to each other. This is one of the area that we have some other reason use also, where we use asymmetric keys. Okay, and this plan, this idea has been planned by this Diffie-Hellman guys. Is called key exchange. This is called DH algorithm. Okay, this is the one who is helping you to between two parties exchanging the key with your physical medium. That's what I explained to you. Okay, and this is not the only one. Same thing can done by RSA also. So RSA also the algorithm who is helping you visually somewhere, helping you to exchanging your keys. So this is also a key exchanging algorithm we can use. Maybe somewhere you can write. I don't know. Somewhere you can find this stuff. This again, you can use for key exchange. Here, key distribution. It is also known as key distribution. So we use this thing for the key distribution purpose. Okay, RSA. Now, point here is that this is the concept I explained to you. One task I have already given to you. If you just forget of this diagram, even though guys, if we talk about this diagram, okay, in this diagram, guys, is also hackable. Okay, so we have some way, and that's very interesting, that hacker can break this setup. Okay, this kind of way or protocol. Okay, now it doesn't matter RSA use or DS use. The only difference RSA and DH is not DSA. DSA is a different concept. Okay, so only difference between DH, sometimes DS is also known as DHE. Okay, DHE. Why this? Because after Defi, Hellman, there's one more guys who also work a lot in this area. This called Markle. Okay, so they also want to recognize this guy, Ralph Markle. So they use this file, they rename it, or they use this one more name called DHE. So either use DHE or DS, same algorithm. So only difference in this algorithm and RSA, these are two different, like DS or ES. So DHE or RSA is the internal mathematical formula, the idea what they use behind it, like algorithm they use behind the scene. Okay, I'll tell you both the algorithm very quickly in some minute. Okay, what they use. Okay, so this one thing. So RSA used for sharing symmetric key. But I guys told you last day, I think 2 classes back, even though they are so powerful algorithms, if you talk about all the supercomputer in the world, if they work for thousands of years also, they won't able to break it. But when the quantum computers come in the real world, even though they already exist, but when they reach to the public market to use, okay, that time these algorithms so powerful can be breaked. Okay, I'm not talking about the setup break. We snip the packet. It's not like this break. They literally break the algorithm. They will find out your real keys. Okay, one of the very powerful algorithm in the quantum computer is called Shor's algorithms. Okay, Shor's algorithm. So even though this level of key also will be broken by the computers. So in my quantum computer training, this is I delivered that I explain the Shor algorithm very detailed, even though I showed some demo also there about the Shor algorithm. Okay, so when the quantum computer come in the real world, right, it's been available to hack a public eyes. There's no meaning of security right there, and without security, nobody can use the internet. We have different the way in the quantum world to secure. There's different point, but these algorithms won't be. We go for RSA, Diffie-Hellman, ECDH C algorithm or ECDHE algorithm. Also one famous algorithm in the market, ecliptic curve. Okay, whatever you have, they will break it. Okay, in the Shor's algorithm. The structural knowledge I'm talking about, I'm just giving this information to you. This is one thing. But let's talk about the RSA and the DSA. Okay, so if you guys try to understand how the RSA and DSA work behind the scene. Okay, what is the idea? Okay, about the RSA and the DSA. So guys, let me talk a little bit very interesting. Okay, I'm like trying to explain you a little bit more deep into this algorithm, how they work. Okay, how they work, the protocol perspective. Okay, so so in the RSA or DSA, there's one interesting concept. Okay, the one interesting concept. For example, okay, if you try to understand the RSA algorithm as a mathematical perspective or algorithm perspective, RSA. Okay, how they work. For example, okay, if I take two numbers, and they're to the prime number, I think you guys know what is prime number. It's not divisible by anybody. Let's say 7. Okay, and I take one more prime number, 5. If you know two prime number, you can multiply, you get the answer. Okay, but if I do in the reverse way, if I give the number to you and if I ask you, can you find two number P and Q? I don't know what is P and Q. Can you tell me what is P and Q? If I multiply, I get 35. Condition would be P and Q should be prime number. Okay, can you equate this? Typically, guys, in mathematics, if it's a 6, how can you get the 6? 2 into 3. If it's 8, how can you get the 8? 2 into 4. Or maybe 2 into 2 into 2. Multiple way we have. This is called factorial problems, right? Factors, factor number, or factorial, not factorial, factor problems we have. Okay, this factorial is a different thing, this factor problem. Okay, again, this is a vector problem. I'm giving you the 35. Can you tell me two number? Okay, can you give me two number? Okay, I don't want two number. If you multiply, it should get 35. But these two numbers will be prime number. Can you give? Right now, this number is very small. I can try 1 and 35, not 1 and 35, 2 and other number, 3 and other number. This number is very small, we can get it. Okay. But if this number is very big, okay. For example, if I just ask you, can you give me, okay, can you give me that 3127? What is P and Q that give me 3127? Okay, what is P and Q? And P and Q should be the prime number. Can you give this? Okay. Again, this number is very small. Okay, if you try to calculate somehow by calculator something, maybe in some minute you will get that this may be, I think, 53, I think, and this may be 59. Okay. But if you talk about a very big number, okay, of hundreds of digits and thousands of digits, okay, if I give this kind of bigger number, okay, and let's say the formula would be, let's say n equals to PQ, P into Q. I give this number, and the size of this number may be, let's say, around 1,000 digits and more. And then I say find P in Q. Now, believe me, technically, first of all, there is no formula available in the mathematics for this. Okay, there's one thing. Okay, there is no formula for this in mathematics. Second thing is, if you try to do by brute force, you know, means one try with other thing, multiplier, 2 multiplier, 3 multiplier, 4 multiplier, and try to find all the prime number, keep on multiply the numbers to find this number. Okay, if you try to do this kind of way, this is called brute force way. So the biggest supercomputer in the world takes thousands of years to compute this. This is the one of the very big problem we have. Okay, big problem we have, or one of the very complex problem I can say in terms of time complexity problems. Okay, we can't find it. Okay, and this is the exact formula used in the RSA. In this RSA, okay, in the RSA, this 35 is known as public key, and P and Q is known as private key. Private keys. Okay. So when I ask you that create a private key by this command, I don't know have you noticed or not. Let me run with this command one more time. Okay, when you run this command, you know, this command internally create two random very big prime numbers. Okay, because when you run this command again, okay, they create two prime numbers and they arrange this prime number somewhere either here somehow in some kind of different format. But here they have two prime numbers. We can get this prime number very easily from this private key. We have the command for this. If you don't know the command, I'll tell you the command very quickly. But we can get this command, private key, out of it. Very quickly, I want to see this. Let me show you. Let's say this is the data I'm storing in my.key, for example. From this file, if you want to get the private, from this private key, you want to get the prime numbers. Then in OpenSSL, we have a command that is RSA key, and from this key, my.key, I want to print this data in a normal format. Okay, so I want to convert it to text format. Okay, and I want to print out in my screen. So they convert this data into normal text format and they print out in the normal format. Okay, so in the private key, it is composed of two prime numbers. A lot of things come up. This is not important right now to discuss. Okay, but this is the prime number 1 and prime number 2. Here they're present in the hexadecimal code. But if you convert this number into number format, okay, it will be very big number. Let's say here was 53 and 59. Okay, very big number. Okay, so if you know this number, then you can convert into this one. But if you only know this number, it is impossible to convert. Find this two. Okay, and what we do, we multiply this number, and the result of this number we store in a public key. So what a public key is, what is the result of is a result of these two numbers. Even though we do some more operation after the multiplication, then after multiplication, we do some kind of mode operation, mode. So that's why this become a little bit smaller compared to this. But typically, there's a different point. But this is what your public key is. Okay, public key is. Okay, so point, guys, here is this is what the RSA asymmetric algorithm is. Okay, even though DeFi has been also doing something like this, they have there's a different formula for this. They work on the logarithmic formula. If you want, I'll tell you in a minute. But even though if you see also they're working on the difficulty factoring of two big prime numbers. Okay, and making the RSA is not an RSA problem. We can't do it. Okay, but if you go to quantum computing, that's what they was doing it. So they find a way to find the prime number. Okay, in the source algorithm with the help of quantum computers. And this is very, very big. If you guys understand this level of complexity, very much computing power need we don't have in the supercomputers, but yeah, quantum computers can break it. I think just within a minutes also, they break this and find the prime number. After you know the prime numbers, that's all, you break. Prime number is here equals to a private key. So private key is nothing, just to do prime number, and this was the formula they use behind the C. Okay, if you talk about RSA, okay, RSA. But if you talk about Diffie-Hellman, they also use similar concept. The formula is different in Diffie-Hellman. Okay, in Diffie-Hellman, the formula would be, I think, the using would be something like this. For example, if I give you, if I say I have some number 12, and I'm going to give a power of 12 something, and whatever result come up, I will do a mode with 7. Okay, a mode with 7. Okay, and in this case, if you try to count, Barson, with this data I already have right now with me, is 3. Like 12 to power 5, if you just try to calculate, let 2, 4, 8, 8, 3, 2 come up. And if you mode with 7, your modulus I showed you in my last class, modulus of 10 or 7. If you divide the 7, the remainder, if you see, is 3 gonna come up. Okay, gonna come up. Okay, so in this case, if I give you, let's say, if I give you this information, if I give you this information, if I give this information, but if I don't give this information to you, okay, then in this case, this information is your key. It's a private key, and all this information will be a public key. Okay, from this public key, if you're trying to find the private key, is we can have the mathematical formula for this, but it takes thousands of years in supercomputer, thousands of years, okay, to compute this. This is a very small number right now. I'm talking about the big numbers, and some thousands of digits or hundreds of digits I'm talking about. And that context, okay, this will take thousands of years to calculate. Okay, so what I'll keep, this big number is my private key. I keep secure with me. I don't want to give it to anyone. Okay, and these are the big numbers. Okay, I'm going to give in a one file called public key. Okay, and in the public key, they use this number to, there's again some formula. Even though this problem is this you can't be able to find it. This technical, problem also a name. This is called discrete logarithmic problem. Problem means if you don't know this number, okay, so from these number is very harder with the computer speed I'm talking about. Logically, practically, we can do it. Okay, we can add the formula, but computing is the big answer. We weren't able to compute it. That was the challenge. Now the supercomputer can do it. That was the challenge. Okay, so in this case, this we have. Now again, this 3 information, whatever data they have, okay, they dump this data into this some other number. By this number, Okay, and again, there's again some more mathematical number come up. I don't want to go for that action right now, but this is the idea, guys. I think not from Diffie-Hellman, okay, at least from the RSA, you might get more clarity. That is a little bit simple to understand the things, right? Okay, so my point here is in RSA they use two prime number as algorithm perspective. They won't give this number to you. They only give the public key. That is your final result. Okay, and this number we use. Okay, you use to encrypt the data. Okay, so whatever data they have, or whatever data they have, let's say I have the hello. I want to encrypt the hello. We use this key, let's say 3127 to lock it. How? Again, we have some mathematical formula to lock it, but the formula is getting such a way. If you lock with this number, you won't able to find it. The actual hello again, and that formula mathematics, only way to find the actual hello is to use their prime number vectors. So there's some mathematical formula for this we have. So if you log this data out to do something on this data with this final number 3127, for example, okay, to unlock this data to get your data back, okay, same formula, the way the formula we have, you have to give two prime number, then only work it. So you can find this kind of formula in the market, but yeah, right now my point here is not to go in the mathematics technically, but by this you guys get the idea why breaking the RSA and the Diffie-Hellman Diffie-Hellman key or Diffie-Hellman algorithms is impossible. Technically possible, logically possible. We don't have a computing power. That was the big challenge.